That section was about writing formulas. This section is about naming ionic compounds. So all of the ionic compounds that we'll run into and need to name in this class and in Chem 1A only have two ions, one cation, one anion. And we always list the cations first and the anions second. It's just a convention. I've told you, I think before, that I think of metals as being masculine and nonmetals as being feminine. Cations are almost always metal ions, and the anions then are nonmetals, so cations are masculine and anions are feminine in my fantasy chemistry land, right? So if you're addressing an invitation to a formal event, is it Mr. and Mrs. Smith or Mrs. and Mr. Smith? It's Mr. and Mrs. Why?
The male first.
Why do we put the male first? Because it's tradition, right? Everybody does it that way. Does it really have any significance? Not really. Some people want to read stuff into it, but that's just a waste of emotional energy. It's just because we put the cation first, because that's how we decided to do it. But we're all going to go along with it, and we put the cation first, Mr., and then Mrs. So cation, then anion. So naming these, what we need to do is separate the two ions. We're starting with a chemical formula. What we need to do is we need to take the formula apart. We just learned how to put it together. Now we're going to learn how to take it apart again. Separate those two ions, identify their charges. Sometimes we need to figure out what the cation charge is by looking at the anion charge and looking at the ratio of the ions, and I'll show you how to do that. Other times we can just look at the periodic table and know what the charges are. Then we're going to name the cation first, and we'll name the anion second, and we'll leave a space between their names. Because when you write your name, if you're named John Smith, you write John and then a space and Smith, right? Because that's what we do. Compound names are the same way. There's usually two words in them and there's a space in between. They're not capitalized though, because they're just chemicals. They're not proper nouns. And here's a little reminder. Metals that are not in groups 1A, 2A, 3A, zinc, silver, or cadmium, that little triangle there, you need to put a Roman numeral indicating the charge in the name. So let's do some examples. So here we have a chemical formula, CaCl2. How do we know if this is an ionic compound? If there's a metal. So it's almost always the first element. The first element is calcium, which is a metal. That tells us this is an ionic compound. So when we have an ionic compound, what we need to do is we need to separate this into two ions. Usually it's the first element and then everything else. So I'm going to draw a line there. Only separate it into two ions. So we've got Ca and we've got Cl. This is not, Cl2 is not a polyatomic ion. It's just chlorine. The reason there's a 2 here is so that the charges will add up to 0. That's the number of chloride ions. So I'm not going to bring the 2 over here. Now I need to put charges on these. What's the charge on chloride ion? -1. We know that from the periodic table. What's the charge on calcium ion? 2+. It's in group 2A in the periodic table. So now I'm going to name them. What's the name of this ion? Calcium. Does it need a Roman numeral? No. It's in group 2A. Doesn't need a Roman numeral. And then this one, what's the name of that? Chloride. It comes from the element chlorine, but it's chloride because when a non-metal gets together with a metal, she changes the ending of her name. So there we have calcium chloride. let's do ZnO. Well, there's two elements here. I'm just going to cut it in half. The first one is a metal, and that's what tips us off to this being an ionic compound. So we're going to separate it like that, and then we're going to write those two ions and put charges on them. What's the charge on O when it forms an ion? 2 minus. What's the charge on Zn? 2 plus. So the element Zn is zinc. So zinc, and then oxygen is oxide. Does zinc need a Roman numeral? No. Groups 1A, 2A, 3A, zinc, silver, cadmium. Zinc doesn't need a Roman numeral. So there's the name, zinc oxide. And yes, that is the same stuff that is one of the active ingredients in many sunscreens. SnF2. What are the two ions there? Sn and F. We're not going to carry this 2 over. This is a monatomic ion. The 2 was just telling us there's 2 of them. What's the charge on Sn? We don't know. Okay, skip that one for now. What's the charge on F? -1. Knowing that the charge on F is -1, and knowing that we have 2 Fs for every 1 Sn, could we figure out what the charge is on the Sn? Yes, we could. So this might be helpful. I have 2 Fs, 2 fluorides, and so that has a total charge of -2. That tells me the total positive charge has to be +2. +2 charge is shared by only 1 tin ion. We know there's 1 because there's no subscript here. So if the total charge has to be +2, then this tin ion must have a +2 charge. So we can figure it out from the charge on the other ion. And then we have to consider what that ratio is. So what's the name of Sn2 plus ion? Tin, and we need to put Roman numeral 2 in parentheses, and then the fluorine is fluoride. It's UO. It's not OU. I see a lot of this. That's fluoride, right? Fluoride is gluten-free. There's no flour in fluorine. That's not right. Any questions about that one? Let's do this guy down here. Mn3P2. Well, we've got Mn and we've got P. We look at the periodic table. We see that Mn is in the middle of the transition elements. We don't know what its charge is from the periodic table. So we're going to skip that one. Phosphorus, we can predict its charge. That's going to be 3 minus. So if this one is 3 minus, and we have 2 of them, what's the charge on the manganese going to be? It's going to be +2. So I'll draw pictures for those of you who don't just see that. So P2, I'm going to draw 2 of these, and I'm going to figure out, okay, the total negative charge is 6. That tells me the total positive charge has to be 6. Mn3, I've got 3 of these here. This total +6 charge is divided equally among these 3. That means that each of them is 2 plus. You have to be fair here. And you can't have fractional charges. It's got to be whole numbers. So then what's the name for this compound? Manganese. And it needs a Roman numeral, right? oops, I almost spelled it wrong. Let's start that over again. Manganese. The charge is 2, so I'm going to put the Roman numeral 2 in there. And phosphorus becomes phosphide. Any questions?
The charge, the Roman numeral is always going to be the charge.
The Roman numeral is the charge. It's not the number of ions. So manganese 2. This is Mn3. That's because there are 3 of these, but the charge is 2. Okay? And that's a real common mistake that students make. They see a name like this, manganese 2. Oh, it's Mn2. No, 2 is the charge. Okay? So, writing formulas of binary ionics. I just want to make sure I didn't skip a slide. Write the formulas with charges for each ion. These are the steps. Use the charges to figure out how many of each ion are in one formula unit. So let's do one more example. Write the formula for aluminum sulfide. I need to write the ion formulas first. Aluminum ion. Well, aluminum is Al, and there's no Roman numeral. That means I should be able to figure out from the periodic table. Aluminum is in group 3A. It has a 3+ charge. Sulfide. Well, that's from sulfur. We look at the periodic table. We start at argon and count backwards. -1, -2. Sulfide has a -2 charge. And then pick your favorite method for figuring out the relationship. We could do the crisscross thing here. We could think about it. We could draw pictures. We're going to end up with Al2, I almost did O, S3. Okay?